All right, good morning, everybody. Today we are going to learn how to do one more factoring technique. And that factoring technique, a couple things have to be true. One, your first term and your last term must be what we call perfect cubes. So, what are perfect cubes? We'll talk about that in a second. Um, Before, remember, we were doing perfect squares, and we said if you had difference of perfect squares, so like if this was x squared minus y squared, that would factor into x plus y, x minus y. And if this was x squared plus y squared, then that's when we started talking about imaginary factors. So factors with I in them. So we're going to take it a step further, and we're going to talk about how do you factor the addition of perfect cubes and the subtraction of perfect cubes. Now you might be happy to know that there will not be any imaginary anything, at least in the factoring part. If you were to solve these, you would get usually two imaginary solutions. So let's just start off with the basic, and we're going to talk about, so what are the perfect cubes? Well, it's any number raised to the third power. So 1, if we take 1 to the third, which is not 3, 1 times 1 times 1 is 1. 2 to the third, which is not 6. I see that so much. People think that 2 to the third is 6. 2 to the third is 2 times 2 times 2. That's 8. Because 2 times 2 is 4 times 2 is 8. 3 to the third, 3 times 3 is 9. Multiply by 3 again, you get 27. 4 to the third, 4 times 4 is 16. Multiply that by 4 again, 16 times 4, and you get 64. 5 to the third, 5 times 5 is 25. Multiply 25 by 5, you get 125. And then we have 6. 6 times 6 is 36. Multiply that by 6 again, you get 216. 7. 7 times 7 is 49. Times 7 again is 343. 8. 8 times 8, 64. Times 8 again, 512. And then finally, well, when I shouldn't say finally, because there's an infinite amount of perfect cubes, it's just usually most worksheets don't go higher than these numbers. So keep in mind that there are an infinite amount of perfect cubes. But 9 to the third, 729. And yes, I did use the calculator for that one. I cannot do 9 times 9 times 9 in my head. Okay. All right. So the important thing, I think this factoring stuff is actually pretty easy. The key is you have to make sure you pick the correct one. So you have to make sure you either pick the plus one or the minus one. How do you know which one? Well, see how this has a plus? So since it has a plus, you would pick the plus one. Since this has a minus, you would pick the minus one. So it's really that simple. Now, in order to use this formula, you have to write your factor as something to the third, something to the third, and then you have your xy. And once you have your xy, you just plug into, I guess you could call this a formula. This will tell you what to do. Okay. So let's start with the first one. And I'll try to keep that top formula on the screen. So we are going to try to write this as something to the third plus something to the third. If you could write it like that, then you'll have your x, you'll have your y, and you just plug into the expression. So first one, x to the third. What to the third is x to the third? That's super easy. That's just x. So x in parentheses to the third is the same thing as x without parentheses to the third. Now here, what number to the third is 64? Well, looky here, this little table we made makes it easy. It'd be 4. So I put 4 to the third. Okay. So what I'm going to do on this is everywhere I see an x, I'm going to put an x. Everywhere I see a y, I'm going to put a 4. Okay. And I might even put that down there just to remember that this is x. And this is y. All right, let's see what we get. And we're going to use the plus one because ours is a plus. So what was x? Well, x was x. And it goes parenthesis x. Then you put a plus sign. And then what was y? Well, y is 4. Then I put a 4. Close my parentheses. Open my parentheses just like it says. And then it says to take my x squared. Well, x is x, so I do x squared. Do a minus. And then it says to take my x times my y. Right here, see? So x is x, which x isn't always x. I usually use the letters A and B when I write this out, but I'm using someone else's notes. So x is x, y is 4. So this formula says take x times y. So we're going to take x times 4, which is 4x. Then finally, it says do plus. And it says to take your y value, which y, what to the third, ours is 4. So you're going to take 4 because that's y, and you're going to square it, that'd be plus 16. So we just factored x cubed plus 64 into x plus 4 times x squared minus 4x plus 16. Now we would factor this, but there are not two numbers that multiply to 16 and add the negative 4. And in fact, on all of these, to my knowledge, this part will not factor. So all you have to do is this one step. Okay. All right, let's look at the next one. And I see a minus, so I'm going to try to make a mental note to use the minus one. So I need to write this once again as something to the third. Well, this isn't going to work too well. There's no way to put z to the fifth to the third. I failed to mention this before, but when you're working with the exponents, in order to it to be a perfect cube, it has to be a multiple of 3. So it has to be x cubed, x to the 6th, x to the 9th, x to the 12th. Z to the 5th is not a multiple of 3. So we cannot use difference of cubes. However, there is a GCF here, so let's factor that out. Looks like the GCF is, oh, I know z squared for sure, because they both have a z squared, but GCF of 16 and 250. Let me see if I could. 16 and 250. Oh, 2. I guess that'd be 2, just 2. So I'm going to take out a 2 z squared. see what's left. And remember, we did GCF before, so this part should not be new. 2 times what is 16? That'd be 8. And I'm thinking good, because 8 is a perfect cube. 16 was not. Okay, so we're on the right track. Z squared times what is z to the 5th? I need z to the cubed. And remember I said, in order for it to be a perfect cube, it has to be a multiple of 3. Well, 3 is a multiple of 3. So we're on the right track. That's great. 2 times what is 250? That'd be 125. Again, good news, because that's 5 cubed. And then we have z squared that we factored out. So we know that both of these are going to make perfect cubes. So what we're going to do is we're going to write this as something to the 3rd minus something to the 3rd. And the reason why we're going to do that is because whatever is here will now be x, whatever is here will now be y, and then we just plug into the little formula. So let me think. What number to the 3rd is 8? That's pretty easy when I have a chart sitting right in front of me. That would be 2. What to the 3rd is z to the 3rd? That'd be z. By the way, I put a little mark through my z's, or else my z's and my 2's look just alike. And then what number to the 3rd is 125? Look at my chart, that's 5. So what do I have here? I have that everywhere I see a 2z, that's going to be x. So I'm going to put in a 2z here, 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 okay? So I'm going to plug in 2z for all the x's. And I am going to plug in a 5 for all the y's. So I'm going to put a 5 here. Nope, that's not a y. I am going to put a 5 here, a 5 here, and a 5 here, which makes 25. I am going to put a 2z in for x. So that's going to be a 2z. That's going to be a 2z squared, which is 4z squared. And then that's going to be 2z times, we said y was what, 5? So all we're going to do is we're going to plug in at that point. So pretty much what I just said. Let's see. X, 2z. And then a minus. Then it says to put the y. Well, y is 5. Notice y is not negative 5. You don't carry that sign over because it's part of the factoring formula. So I got 2z minus 5. That's my first factor. And then it says to take my x squared. Well, my x is 2z. You take 2z times 2z, you get 4z squared. And then it says to take your x times your y. So it'd be 2z times 5, that's 10z. So, and it's a plus 10z. And I ran out of room here, so I'm going to put it down here, which doesn't look great. And now I need to take my y and square it. Well, what's my y? My y is 5, so it'd be plus 5 squared is 25. And again, I ran out of room, so I'm going to put it here. All right, I factored it. Okay. Excuse me. Now, if you're not sure if you're right or wrong, remember, you could type this in a Desmos. You could type this in a Desmos, and they should make the same graph. This is just in factored form. This is in, I guess you'd call that standard form. Okay. All right, so I showed you 2 examples so far. Once you get the hang of these, they're pretty fast. I know I kind of went through these kind of slow, but I mean, they really aren't that long. So the first thing I always do, I write down the formula that I need. So I remember that plus, I'm going to put the plus formula. So the plus formula says you take x cubed y plus y cubed, and then you do x plus y, and then you do x squared minus xy plus y squared. And again, all I did was copy from up here. So that's usually what I do first. I write down the one I need. And then I try to rewrite this. So I go, okay, let me think. So this is going to be something to the third plus something to the third. And then I see that x to the third is x to the third. And then I ask myself, what number to the third is 8? Well, that'd be 2. And then essentially, everywhere I see an x, everywhere I see an x, I'm going to put an x. Everywhere I see a y, I'm going to put a 2. So it becomes as simple. X is x. Y is 2. X is x. Take x times y. That'd be x times 2. Take your y squared. Well, y is 2, so that'd be plus 4. These don't take too long once you get the hang of it. B. So again, I always like to write down the formula. So this one, looking on top, is a minus. So I'm going to pick the minus one. So I'm going to go, what is it? X cubed minus y cubed is x minus y times x squared plus xy plus y squared. Okay. And then I ask myself, actually, let's do this. I ask myself, what to the third minus something to the third? Well, when I break down 8, 8 is going to be 2. So 2 to the third is 8. And then you still need an x, so it's going to be 2x. And then 1, this is the one people forget, that 1 to the third is 1, so this stays 1. So now, everywhere you see an x, you put a 2x. Everywhere you see a y, you put a 1. So everywhere you see an x, you put a 2x. Everywhere you see a y, you put a 1. So this is going to be 2x minus 1. And then you're going to square your x. Well, x is 2x. 2x squared is 4x squared. Take your x times your y. X times your y is 2x times 1, 2x. And then take your y and you square it. The y is 1, so it'd be plus 1 squared, which is just 1. All right. Let's look at one last example. And it might look hard because they're large numbers, but 512, here we go. It's 8. 8 to the third. 216 is 6 to the third. So it's exactly the same way. I kind of ran out of room here. I guess I'll do it way down there. So I'm going to do this problem over here. All right, so I need the minus 1, So here's the minus 1. I'm going to copy this one again. X cubed. And again, this is for this problem. I'm just writing it down here. I ran out of space. So x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. All right. So I need to write this as something to the third. I need to write that as something to the third. 512, go to my table. That's why it's there. 8. 8 to the third is 512. So this is going to be 8 because 8 to the third is 512. M, what to the third is, or what to the third is m third, would be m. Now we didn't do an example like this, but let's say this was m to the sixth. Well, you would need to make this an m squared because 2 times 3 is 6. I know we didn't do any examples like that. And then what to the third is 216, 6. So in my formula, everywhere I see an x gets replaced with an 8m. Everywhere that has a y gets replaced with a 6. Everywhere that has an x gets replaced with an 8m. Everywhere with the y gets replaced with the 6. We said x gets replaced with 8m. 8m squared, let's see, 8 squared is 6, so it's not 16. 8 squared is 64. So you have 64m squared. You take your x times your y. So what is 8m times 6? 8 times 6 is 48. 48. And then finally, I do 6. I'm sorry, y is 6. That'd be 6 times squared is 36. Now I look at this now that I'm done, and I notice that this is not completely factored. Why is it not completely factored? Because I see that there's a number that goes into 8 and 6. There's a number that goes into 64, 48, 36, partly because they're all even. So I really should have taken that GCF out from the beginning. The GCF, let me think, of 512 and 216 is 8. So I should have divided both of these by 8 first. No worries, we still can. We can still do it at the end. 8m and 6, GCF is 2. So I'm going to take out a 2, which is 4m minus 3. And then the GCF of 64, 48, and 36, I believe it's 4. So you can take out a 4. I definitely ran out of room here. 4 times what? 64, 16, 48 divided by 4, 12, 36 divided by 4, it's easy, 9. And so now if I was to write this as an answer, which I'm not, and it's really not an answer, it's a simplified factored form, I would take 2 times 4, which is 8, and then put the other factors together. So I would just say 8, 4m minus 3, 16m squared plus 12m plus 9. Technically, this above line is correct, but it's not completely factored. And it would have been a lot easier had I just saw the 8 from the beginning. But you can always factor out GCF at the end if you don't catch it at the beginning. So what I want you guys to do for practice, and it's just the odds. Okay, so just the left side of the page. Go through and practice. They start you off pretty easy. Remember, they don't take very long at all. And then I guess you could call these trickier. They're just larger numbers. They're not really tricky. So that is what I want you guys to do for practice. There is also a quiz out there, but other than that, I have finished. And you should know, again, the goal is that you could use these two new factoring techniques. One is for sum of cubes, one is for difference of cubes. So if you feel good about that, you're great on the lesson, and I'll see you later. Feel free to join my office hours. I'm going to sign off. Nice seeing you all, and go Chiefs.